2021, on the eve of Christmas, this telescope was launched into space. This project was organized and executed by three major space organizations: the NASA, the European Space Association, and the Canadian Space Association. The NASA is responsible for the overall Webb mission. European Space Association provided the launch vehicle, the launch site, and the near-infrared spectrograph, an instrument used in this telescope. And the Canadian Space Association contributed by providing the near-infrared imager and slitless image spectrograph, etc. Let's talk about the mission goals. The mission goals were search for first galaxies formed in the early universe, and to study galaxies near and far to inform the evolution of galaxies, to observe the formation of stars from young stellar nurseries to the formation of planetary systems, and to measure physical and chemical properties of different exoplanets around the Earth. Let's talk about the launch. Ariane 5 rocket was used for the launch of this telescope. It consists of two stages, a lower composite stage and the upper stage. It used a combination of solid and liquid propellants. The total powered flight time is about 27 minutes. It consists of a payload adapter, which is responsible to separate the Webb telescope from the rocket after it reaches the space. It consists of a payload fairing, which protects the Webb from the atmospheric drag and heating during the ascent. The launch site is very specific because it is located close to the equator, where the rotational speed of the Earth at the surface is greatest. Now we can talk about the launch timeline. The launch was segmented into various steps. After the launch, the sun shield will be deployed. After that, the mirrors are deployed, and the telescope will reach the L2 location. After that, telescope cooling process will start. The telescope is aligned, and the first image and spectra were taken after 6 months. Let's talk about the orbit of this telescope. The Webb orbit follows a special path around the L2 Lagrange point that is directly behind the Earth. This point is an ideal location for astronomy. It is actually a halo orbit around the L2 location. This orbit ensures that one side of the sun shield is continuously faced the Earth and to block the view from the telescope orbit. Next, there is a commissioning process which the Webb telescope undergoes for 6 months, during which it fully deploys, cools down to operating temperature, and align to observe the space. You can see in this image. You can see the commissioning process. You can see in this image. After that, this telescope uses infrared light spectroscopy. Now we can see why this telescope uses infrared light. This telescope basically uses the infrared light to view the celestial object in much greater clarity and sensitivity than ever before. It is used as cosmological redshifting, where the light is stretched as the universe expands. So the light from the stars, when it actually comes from the stars, it is from shorter wavelength. Through the cosmological redshifting, it expands and it reaches the infrared wavelength. So while we are using infrared light, we can observe those celestial bodies easily.
Vignesh, your time is up.
After that, we are using spectroscopy.
Later.
Hello. Yes, ma'am.
Your time's up.
Okay, ma'am. Thank you.
Now it's your interaction section with Judge Love.
Okay, Vignesh, are you hearing me? Vignesh?
Yes, sir.
Yeah, fine. So
yes,
you talk
sir.
about this.
Hello. Am I audible, sir?
Yeah, you are audible.
Hello, I'm audible, sir.
Yes. I have two clarifications. One is so what is the typical temperature of this telescope? Do you know, Vignesh?
The operating temperature of this telescope is very low, sir. Sir, there is a problem through mic. There is a lag, sir.
I'm hearing you. Just tell me what is the temperature. The range is fine actually, because you studied this entire thing, huh?
There is a lag, sir.
What?
Yes, sir.
What is the temperature?
The operating temperature. Sir, hello. Can you? I'm saying, sir. The operating temperature of the Webb telescope is about 75 Kelvin, sir. Very cold temperature, very low temperature.
Okay. So you talk about L2 point, right? The Lagrange point.
Yeah.
So what is the Lagrange point? Why
Yes,
it is L2? Why it is L2?
Yes, sir. Hello, I'm audible,
Yes.
sir. Sorry,
Yes,
sir.
yes. Yeah,
Can you repeat
proceed.
the question, sir?
Yes, proceed. Do you know this? What is
Okay,
L2?
sir. Yes, sir. Yes, sir. The L2 point, because the L2 point is selected for this Webb telescope because it is directly behind our Earth, sir. So it can provide a shield from the sun rays and Earth and the Moon to view the space without any deviations, without any obstacles. It is very easy, and it is an through at this L2 point. At this L2 point, the telescope can achieve its maximum potential. It can easily get the sun rays, required amount of sun rays to work properly, sir. So that the L2 point is selected for this telescope, sir.
I'm just asking about the physics behind these points. Why they are L2?
Okay, sir.
Is there any other points like, because L2 means there is some L1 or something like that?
Yes, sir. There are about 5 points around the. There are about 5 points L1, L2 to L5. The L2 point is directly behind the Earth. The L1 point is between the Sun and the Earth. L4 and L5 are at the I can say பக்கத்துல இருக்குன்னு சொல்லலாம் சார். L3 point is directly behind the Sun, sir.
No, is the only reason why they are keeping is behind the Sun? That is the reason.
So these are also actually imaginary points, sir. They are used for some calculations purpose. I can say that the position in space.
Okay. So which class you are studying?
I'm studying a second MSc Physics, sir.
Second MSc Physics. So you might have come across classical mechanics, right?
Yes, sir.
So there is a 3-body problem. Just go through it and you may know that more details on these L points. Okay. Okay then.
Okay,
fine.
sir. Thank you, sir. Thank you.
Yeah, fine.
Thank you, Vignesh. Next, Ajita Messi, are you ready?
Yes, ma'am. Can I present?
You can present now.
Yes, ma'am. Okay. Good morning, everyone. Now we are going to see about James Webb Space Telescope. The James Webb Space Telescope was launched on 25th December 2021. It was a collaborative work of NASA, ESA, and CSA. The launch took place at European Spaceport located in French Guiana, packed inside an Ariane 5 launch vehicle at second Lagrange point L2. So, what are the major components of this JSWT? The Integrated Science Instrument Module (ISIM), optical telescope OTE. The optical telescope element has the mirrors and backplane. The spacecraft element, the scientific instruments such as NIRCam and NIR spectroscopy, MIRI, FGS, NARIS. Here, the optical unit that consists of lots of IR cameras and sensor should be operated at very low temperature, that is below 50 Kelvin. Then the med IR instrument even cooler than, it should be operated even cooler. So it should be operated 5 Kelvin, or that is about 450 minus 450 degree Fahrenheit. So it is fitted with a helium gas cryocooler. What are the special features of James Webb Space Telescope? The primary mirror. It has 18 hexagonal fragments coated with a gold. Here, the gold plays an important role as it absorbs the blue light and it reflects the red light. That is, it reflects the infrared light very effectively. So that we can get the high resolution images of the galaxies and etc. A sun shield. The sun shield, it is about of a tennis court sized. It is a multi-layered one. So it blocks the excess heat that the from the sun and the earth. It blocks the excess heat from the sun and the earth, and it makes the entire equipment cooler so that its effective functioning may be done. So the MIR, the mid-IR instrument is fitted with a helium gas cryocooler, that is cryogenic liquids are fitted. So what are the objectives? Why we are calling this James Webb Telescope as a game changer? Why it, as we all know, it is a successor of Hubble Space Telescope, which was launched in 1990s. Okay, what are the main objectives of James Webb Telescope? Is it should observe light from the first generation of stars and galaxies. That is, we are going back in time. We all know that the galaxies, the universe, have been formed from Big Bang theory almost 1.8 billion years back. In order to get the images and pictures and to study about the first generation stars and galaxies, we are using this James Webb Telescope, and to identify exoplanets with habitable properties. This means that exoplanets means the planets other than our solar system. So if we can find the habitable properties, how means the starlight reflected from those planets are detected by this James Webb Telescope, and by the examination of the composition of Earth. So if the carbon dioxide and methane, etc., if there is any difference in the composition, we can say that is there any human living possibility, or already there are any living beings, or it is possible for us to live there. So we can also find a new Earth outside. Okay, next, to research the evolutionary origin of planetary systems. So how the planets, how the galaxies have been formed. So in order to find that, we are using the James Webb Telescope. So these main objectives, these marvelous features makes this as an game changer in this new age of astronomy. So why JWST is more effective than HST? HST can only survey the visible region and ultraviolet region, some of the near IR radiations. But as the cooler bodies like stars and galaxies emits IR radiation, that is, as the universe is expanding, the wavelength is shifted to visible to the infrared region. So this as this JWST is an infrared observatory, it could effectively collect the longer wavelengths, that is higher wavelengths, and it can give more resoluted pics than the Hubble telescope. Then JW's images are extremely clear and specific than HST. The unfolded form of primary mirror of JWST, that is the gold-coated mirror, gives 25 square meters of a clear aperture. That is, across it is about 6.5 meters. So it has a larger area, so that it can collect large amount of IR wavelengths. But whereas the HST gives only 4.5 square meters. Webb's mirror fragments are made of beryllium. So beryllium is light and strong. In order to work these things in the space.
Time's up, Doc.
Yes, ma'am.
Time's up, Doc.
Okay, ma'am.
It's
Thank
time
you.
for your interaction section.
Okay, ma'am. Thank you. Sir? Yes, sir. Yes, sir.
So, what is the typical temperature of these mirrors?
Sir?
What is the temperature? The required temperature for the mirrors?
Mirrors extremely low temperature, that is below 50 Kelvin. below 50 Kelvin.
Why below 50 Kelvin?
They have to be operated if the heat, sir.
Is there any physical reason?
Apeiron 2022.
The IR sensor should be operated in low temperatures because as the telescope is working, the heat from the telescope itself may damage the capability of those sensors. So it should be always kept at a low temperature.
So you talked about something like L2 point.
Yes, sir.
What
Yes, sir.
is it?
So that is a point where the gravity from the sun and the earth, that is the gravity and the orbital motion is balanced, and it is almost about minus 230 degrees Celsius. So it is of course it is a very low temperature, so that this JWST can work efficiently there, sir, and it is made out it is kept out from the shadow of the earth, so it can be effectively worked there, sir.
Is there any other points why they are taking particularly about L2? Because L2 is basically an unstable point, right? You have to supply some energy to stabilize this satellites there, no? You need fuel.
Yes, sir.
So why they are choosing that one, even though it's unstable?
Sorry, sir.
You don't know. What
I'll
class?
go through.
Okay, what
Second.
class? Second?
Second MSc, sir.
Okay, fine. All the best.
I'll go through it, sir. Thank you.
Thank you. Thank you, Ajita. Next, Tuba Anjum, are you ready with your presentation?
I'm sure.
You can present now.
Ma'am, is my screen visible?
Yes, you can proceed.
Very good morning, sir. And very good morning to one and all. So myself, Tuba from Periyar University, Salem. Today I'm here to share some glorious information and very exciting facts about James Webb Space Telescope, which is sculpturing its name in the history of humankind. I have sorted some of the content which we are going to see today. First, I will start with the introducing James Webb Space Telescope to you all. So it is a telescope which is designed primarily to conduct infrared astronomy. So it was mainly built by NASA and in collaboration with European Space Agency ESA and Canadian Space Agency CSA. So three organizations joined together and built a very big space telescope ever launched into space. And it was launched on 25th December 2021 on the ESA Ariane 5 rocket from Kourou, French Guiana. So it is a successor of Hubble Space Telescope and very most powerful telescope ever launched into space. So the space telescope was named after James E. Webb, who was a scientist and administrator of NASA from the year 1961 to 1968. So these are some of the basic facts of James Webb Space Telescope. In the figure, they have given the description of all the parts that commemorate this whole space telescope. The total budget cost of this project was about $10 billion. And so it orbits 1 million miles away from the Earth. And it collects light from the stars and galaxies through infrared spectroscopy. We will see this detailedly in the later section. So the important machinery goals of JWST was to measure the planetary systems and investigate for potential life in exoplanets. That's it now in all the space discoveries. It's everything was hypothesis and theories, but still it doesn't have any crystal clear proof or evidences of how the university or galaxies are yet formed. So this JWST will provide evidences and it will give proof and evidences for all the unsolved mysteries of the space. So these are the main missionary goals of JWST. Let's move on to the construction and engineering of JWST. So it has all the main components, and these components are segregated into different divisions. The first, the optical telescope element OT, it contains mirrors, that is primary, secondary, and tertiary mirrors. Then the integrated science instrument module, that is ISIM, that contains mid-infrared instrument, near-infrared spectrograph, near-infrared camera, and fine guidance sensor, and near-infrared imager and slitless spectrograph. In this figure, you can see in left to the figure, they have given the scale of human to the telescope. Now you can see the primary mirror, which is coated with gold and beryllium to receive infrared light, the infrared light will be received in a feeble signal from the distant object. So it is coated with gold and beryllium to acquire as much as infrared signals as much as possible. The light will be, the signals will be fall on primary mirror, then it will move on to the secondary mirror, and then again it will fall on the tertiary mirror. And then the telescope will recognize the signals, how far the distance from the objects, or then how old the objects are. So everything will be organized inside the spacecraft controls. And see, you can see the sun shield layers there. There are 5 layers totally. You can see that in the next image clearly. This image also gives you the base parts of the telescope, that is momentum flap, solar array, spacecraft bus, star tracker. Spacecraft bus is the most important components of the telescope, where we can handle, where the main parts of the telescopes are situated. Then the earth pointing antenna is where the signals will be received and transmitted from the earth. Then these are the step-by-step process of how the rockets are launched and how it will work. In secondary mirror, you can see the reflect gathered light from the primary mirror into the science instrument. As I told you, the components will work by segment. See, in the right side figure, the rocket was launched in the vehicle Ariane 5. Then the solar array deployment in the space, then the sun shield deployment, then the fourth process is secondary mirror deployment, then fifth process is main mirror assembly, and the sixth one is L2 orbit begins. Next, we will move into the parts of JST detail, that is ISIM part, where the infrared signals will be received step by step through 4 components, that is near eye infrared camera, mid infrared instrument, fine guidance, and then near infrared spectrograph.
Time's up.
This is how.
Your time's up, Doc. Now it's your
Okay,
interaction section.
Okay, ma'am. Hello, sir.
Yeah. Tuba,
Yes, sir. Am I audible, sir?
can you explain bit about this L2 point?
Yes, sir. So it is a Lagrange point, sir, away from the sun and the earth, where the gravity between the sun and earth will actually gives a perfect balance for the satellite to be placed there. So
Okay.
that we have chosen L2 point there, sir.
So is the only point available between in the sun and
No,
Earth?
there are totally 5 L points. That is forming a triangle shape between sun and the earth. But specifically for our Webb Space Telescope to place there, scientists made their discoveries that L2 point will be very suitable for our Webb Space Telescope to be placed there.
L2 point is
So
suitable.
because of
Why? Why it is suitable?
why? Because if to the Webb Space Telescope will be moving, sir, it won't be standing in a still point. So to move the Webb Space Telescope, we should give some thrust, the fuel will be used there. So for if in L2 point, if we give a minimum amount of thrust, the Webb Space Telescope can have a movement largely, sir. So for that purpose, they have chosen L2 point.
Okay. So these Lagrange points are specific with the solar, I mean, Earth and Sun system, or it has even Mars as Lagrange point.
No, sir. It's between the sun and the earth points only, sir.
I mean, there is no Lagrange points in Mars.
I didn't saw anything about that, but I was seeing all the L points related to James Webb Space Telescope.
Only okay, fine.
Thank you, sir.
Come on.
Thank you, Tuba. Next,
Thank you.
Gurunanda, are you ready? Gurunanda?
Yes, ma'am, I'm ready. Am I audible?
Yes, you are audible. You can press on now.
Okay. Is my screen is visible? Hello?
Yeah, it's visible. You can
Okay,
press
ma'am.
on now.
Okay, ma'am. Okay. Good morning, staff members and all the students. So we will look for the detailed explanation of all the things about James Webb Telescope. So first, we will start. So what is this telescope means? So from the basic definition that we can use, a device used to magnify images of distant object. So with this definition, we can exactly use this telescope in the field of astronomy, because astronomy is the field related with seeing distant objects, right? So he's the person, Hans Lippershey, in 1608, he invented the first telescope, and this is the first telescope he invented. And he said a definition that for seeing things far away as if they were nearby. So um, this is the evolution of telescope. We particularly see the three types of telescope. This is Galilean, right, in 1609. And with this telescope, he can able to see the largest moons of Jupiter and the various phases of Venus. And the next one is Hubble Space in 1990, almost 30 years ago. And it gives us a clear view of stars and planets. And this now it is James Webb in 2021. What this actually tells us, we will see that. So why space telescopes? Again, we can see from these two images, it is very fascinating and clear. So space telescope gives us more information from the image that we are taking. So we should go for the space telescope rather than ground. And then in space, why should we choose for infrared telescopes? We can see that two images from the taken from visible telescope as well as the infrared one. Okay, so here the infrared. Why we should choose the infrared? We will answer for that question. So this is the Eagle Nebula. Here we can see that there are a lot of dust, and there are some hidden details or hidden things in this dust. But with respect to the visible telescope, it is not seen. But what if we made the telescope which is sensitive to infrared? The result is here we can see that the same image with in infrared. Okay, so here there are many kind of stars are present, and we can able to see. So we should choose for the infrared telescopes, and James Webb is one type of is also using the principle of infrared telescope. Okay, so here we can see the comparison why we call the James Webb telescope as a game changer. From 1990, there are a lot of telescopes also launched into the space, even the Hubble Ultra Deep IR. But it can see about the 200 billion million years above, after the time after the Big Bang, where the Hubble can see only the 480 million years. So this is the comparison. Why should go for the James Webb in order to collect a lot of data? Okay. So now the specifically Webb Space Telescope, which is our James Webb Telescope, the parts it consists of its lots, but we majorly consider three important parts, which is the optical telescope element, primary, secondary, and integrated science instrument model. This consists of a gold plate, which is beryllium coated with gold. It consists of 18 hexagonal elements, and this is the observing side, and this is the sun facing side. There are two main sides that these telescopes have. It is a reflecting telescopes, in fact. So the parts primary mirror, we can compare this primary mirror with the Hubble mirror. We can see that it is 6.5-meter long, and the secondary mirror. This is a primary mirror, and it bounces to the secondary mirror the light, and then it once again bounces to the tertiary mirror, and the integrated science system will help us to process the data. And this is the Lagrange point where we are placing this obviously this telescope. There are five places where the balance of gravitational forces allows a spacecraft to be stationary relative to the sun and earth. In our case, it is sun and earth. So the JST, where we are placing it here in the Lagrange point, which is L2. This is the sequence of how the webs is unfolding, because due to the very large size, we cannot put directly into the spacecraft and launch to the space. So we just put unfold it, and there are many sequences of unfolding. And in one such case, that unfolding gives us an image, which is a recent image or recent update from this web's telescope. How it is actually working? The light comes from the star, falls on the primary mirror, it reflects to the secondary and to the tertiary, and the integrated science instrument model helps us to analyze this data with the spectrum. So we should understand why this Hubble and Webb's are different. Webb's can see the first galaxies form. In fact, Hubble can only see the modern galaxies form. So it just overlaps. It just overcomes the Hubble's limit. Okay. So this is a very important science instrument that it has. It has a camera, spectrographs, coronagraphs, can detect Canvas is actually taking the picture. Spectrographs helps us to analyze the spectrum that camera has taken. Contrast blocks starlight, allowing observation. Okay, ma'am.
Now it's your introduction section.
Okay, so Guru Nanda, okay?
Guru Nanda.
Guru Nanda, okay.
Yes, sir.
So can you explain a bit about these Lagrange points?
Yes, sir. Lagrange point. We have 5 Lagrange points, in this case. The 3 Lagrange points are unstable, which is L1, L2, and L3, which is on the plane of connecting Sun and Earth. So why we are choosing that Lagrange point is that we have 2 advantages. One is when the Sun, we are blocking the light from the Sun, and the Earth is very near to the Lagrange point, which is L2, so that we can easily communicate with our communication system.
Is this L2 a stable point or unstable point?
It is unstable, sir.
Okay, but there are some stable points, right?
Yes.
What are they,
They are 4 and 5, sir.
4 and 5. Okay. So these Lagrange points are specific to Earth-Sun system or any solar, any Sun and
any 2 celestial bodies, sir. In this case, particularly, we are dealing with Sun and Earth.
So how many, to obtain this point, how many celestial bodies?
Celestial system, yes, sir.
How many celestial bodies you require?
Sorry, sir?
For these Lagrange points, how many celestial bodies you need actually?
2, sir.
2 is enough?
Yes, sir, enough.
Okay. Okay, which class you are studying?
I'm studying second MSc Physics from Madurai Kamaraj University, sir.
Okay, fine.
Thank you, sir.
Okay, all the best.
Thank you, sir.
Thank you, Guru Nanda. Next, Geeta Bharti, are you ready? Geeta Bharti,
Yes, ma'am. Yes, ma'am. Yes, ma'am.
you can press on now.
Yes, ma'am. Can I share? Is it visible, ma'am?
Yeah, it's visible.
No, but your slide is not seen.
Present your PPT.
I'm Geeta Bharti. I'm going to talk to you something about a new age of astronomy. And new age of astronomy is nothing but it's a James Webb telescope, and it is a game changer of today. And a small introduction of James Webb telescope, and it is a second generation Hubble Space Telescope. And this is a space telescope, and it is designed to conduct infrared astronomy, and it has a reserve of fuel to keep it operational for more than 10 years, for 10 more years, and observe all places in the cosmic history, and it is looking first star and galaxy that has been formed, as well as form of life, and also how current stars and planets come into life. It took 30 years to build, and the parts are consisting of a primary mirror and a secondary mirror, a sun shield, a spacecraft bus, antenna, and scientific instruments, and a stabilization slab. And the picture clearly shows the parts of this James Webb telescope. And it is an infrared observatory that has been orbiting the sun. It is about 1 million miles from Earth. Infrared observatory is nothing but it is an infrared infrared observation. It is a space observatory which uses infrared light. And it is also used to find the first galaxy as well as in the early universe, and it's see the stars that has been forming the planetary system. And it is the very largest telescope has been launched into space. And this picture shows that even we have launched so many satellites into space, and this is a very important telescope that has been launched because it is the one telescope which shows the origin of life. It is after Big Bang. No other telescopes can see more than this. Only the James Webb telescope can able to see our universe after Big Bang. And from this, we can see that the launch date of this telescope is just 25th December 2021, and the cost for this is 1,000 crores United States dollars. And it's planned for 10 years, but it has been elapsed 2 months These are the two sides of the James Webb Telescope, which has been the hot side and the cold side. The hot side, which is facing the sun, and that is operating at a temperature that is below the boiling point temperature. And the cold side consisting of scientific instruments and mirrors, that is minus 233 degree Celsius and 7 Kelvin. And in Kelvin it is 7, and it is artificially cooled by itself, which the reason it has been cooled by an MRI. It has been attached in the scientific instrument, and it has a cryogenic cool, and this sun shield will always look and this sun shield will always face the sun that blocks that heat, and it will observe only faint heat signals in the universe. And for cryogenic we use liquid helium as a cryogenic to cool. And images of James Webb Telescope. And the first image which has been announced by NASA announced that the first image on February 11, and it has been captured its first image of a starlight, and the first image was a star which is called as HD 84406, and this light from that was captured by the Webb 18 mirror segment located on the primary mirror, which is resulting in a mosaic of 18 scattered bright dots. And the copy of the star will be going into a deliberate hexagonal formation. And the Webb has also taken an impressive selfie using a specialized camera inside NIR camp instrument, which has been mounted into the ISIM, which is nothing but ISIM is a part of the telescope, and the camera is designed to be used for engineering and astronomy purpose. These are the two different images. The first image is a selfie which has been seen. One of the mirror segment is shining brighter, and the other looks very dull. The reason for this is there is a point. This mirror is pointing a star, and the rest of the bright part is pointing a star, and the other dull parts are not pointing. It is in other alignment, so we can see the brighter part at one side, and the dull it is covered by a dull spot at the round of it. And the next image is the first image that has been published by NASA. It is taken by James Webb Telescope, and that is the hexagonal formation of a star. That is the first ever image announced by NASA. And the difference between James Webb Telescope and Hubble. Telescope launched before James Webb, and it has a primary mirror of 18 segments made up of beryllium. Beryllium is nothing but it's a light material that is used for beryllium is a light material that is used because it is maintaining a stable shape and extremely low temperature. So we are using beryllium there, and it is positioned 1 kilometer million kilometer from Earth, and it is located. It's an introduction section.
Is this Bharati Muthukumar? Geeta Bharati. Is this Geeta Bharati? Huh?
So Geeta Bharati, sir.
Okay. So the Hubble has beryllium mirrors, right?
Yes, sir.
So is Hubble or JWST?
JWST.
Okay. So I think you said you talked about Hubble and it has beryllium somewhere. Okay, fine. So why beryllium?
Beryllium is a lightweight material, sir. It is easy for maintaining a stable shape, and it is good for extremely low temperature.
And this telescope is placed a place called L2 point. Do you know?
Lagrange point.
Okay, Lagrange point. So how many Lagrange points are there?
5 Lagrange points, sir.
Okay, so what are they?
Mainly L1, L2, L3, L4, and L5. L2 point is placed behind the Earth, and this Lagrange point is nothing but it is a position in space where gravitational force of the Earth and Sun will produce gravitational force where the spacecraft will be stable, and the consumption of fuel will be less.
Okay. And so this Lagrange points are peculiar for Sun and Earth system, or if I take Sun and Mars, can I have a Lagrange point?
No, sir, it is peculiar for
Sun and Earth.
Earth and
Okay.
yes.
Okay, fine. Thank you. All the best.
Thank you, sir.
Thank you, Geeta. Next, Ajit Mohammed, are you ready?
Is it audible?
Yeah, you are audible, but present your screen. Okay, your screen is visible now. You can present.
In past, we discussed the basics and important things of the telescope. Now we move on to detail. In past, we discussed the interior view and exterior view of James Webb Telescope. Now I'm going to explain the various parts of this James Webb Telescope. In primary mirror consists of 18 separate hexagonal segments. This is made up of beryllium and it is both strong and lightweighted. Each of these mirrors or identical designation of ABCD denotes the three major prescription of a segment. Secondary mirror. It is supported by three shunts. These shunts are almost 25 feet long. They are hollow composite tube and its material is about 1 millimeter thickness. Then shunt shield. The shunt shield separates the observatory into warm. A 5 layers shunt shield keeps sunlight from interfacing and the telescope operates under 50 Kelvin. And then the sun shield protects the telescope from external sources of light and heat like sun, earth, moon, etc. Then spacecraft bus. In spacecraft bus provide a necessary support for the operation of Webb Observatory. The bus has 6 major systems, subsystems of electrical power, altitude control, communication, command, data handling, propulsion finally, and thermal control subsystem. Okay, now we are going to discuss various instruments in telescope based on the imaging, spectroscopy, and chronography too. These are listed below. We can see one by one. Okay. In near infrared camera is a Webb's primary imager that will cover the infrared wavelength range of 0.625 micron. It will detect the light from the earliest stars, galaxies in process of formation. The pollution of stars is nearby galaxies as well as young stars in Milky Way. Next, Webb surveyor design is able to see the first star and galaxies that can be ever formed in the earlier universe. It can detect the objects of 10 million times fainter than a stars visible. Its wavelength is nearly 600 nanometers to 28 microns. See how it is was the clarity. Next, near infrared red spectroscope, spectrograph. In this, we are going to operate over the wavelength of range 0.625 micron. Many of the objects that is Webb will study, the most important thing is first galaxy to form another Big Bang, so it is faint. In this picture, I give how the near infrared spectroscopic observations are possible by hydrogen-rich super Earth for 20 transits using this telescope. In this mid infrared instrument has both camera and spectroscope that sees light in mid IR region. Mid IR region. The range from 5 to 28 microns. It is sensitive detector and it will allow to see the red shifting light of distant galaxies, newly formed stars, and faint visible comets. In near infrared imager and filter spectroscope, it is a part of working will use it to investigate various science objectives like fast light detection, exoplanets, and it has a wavelength range of 0.825 microns. Now, NIR spectroscope it enables you to obtain those hundreds of stimulation spectra in electrochemical system, which is known as microshutter array. In NIR spectroscope, microshutter array cells each approximately is wide of human field have lids to open and close it when magnetic field is applied. With the completion of final observatory integration and testing. Telescope has reached a major turning point in path towards launching with the complication of final observatory integration and testing. In this picture, we can see how the to find the first galaxies Webb's made ultra deep near infrared surveys of universe and planetary, etc. In this era of recombination until around a few hundred millions of years ago from the Big Bang. This is See, this is a video in a new star of study, new star of study of galaxy formation, height of red star during the era of cosmic reionization. This telescope can capture sensitive and high resolution images and multi object spectroscopic. It is occurred during the first billions of years of cosmic history. See, in this, Webb will tell us more about the atmospheres. Okay.
Now it's your introduction section.
Okay. Ajit, are you hearing me?
Sir,
Yeah. So why they are using beryllium mirrors for the telescope?
sir.
Why they are using beryllium mirrors? Are you hearing me? Ajit?
Sir, can you hear me?
Yes.
Hello?
Yes, yeah.
So once again, repeat your question.
So why beryllium mirrors?
I think it is very strong for weight and I think so. It is a good shape for ranging the temperatures at all. It is a good conductor for electricity.
Shape or what is this? It is good.
Sir?
It is good. Good for what?
Sir, it is sir, it was both very strong and light so only, and also it is a good holding of shape in ranging the temperatures.
Good holding of shape.
Yes, sir.
Is it you can say stable, right? Stable
Yes,
at
sir. Yes, sir.
stable, structurally stable for low temperature.
Yes,
Okay,
sir.
fine. So they place this is already there, no? This telescope they placed already in the L2 point, right? It is orbiting L2 point.
Yes,
Is
sir.
it placed on the L2 point? It is orbiting L2 point.
So it is placed in an electric point, sir.
It is placed on the L2 point. Okay.
Electric point by using this telescope, sir. In this telescope, it was placed and was out.
It is just placed, but it's not making
Yes,
any orbit. It's not orbiting, right?
Sir, by using an L1 to L2 is plays a major role for getting when sun temperatures is get very
That is fine. That
very
is
higher, it plays an vital role.
Ajit, that is fine. So I am asking about whether this L2, this telescope is fixed on L2 point or it is orbiting somewhere, orbiting about L2 point.
I think you are asking about whether this is fixed or moving.
Yeah, moving.
This yes, sir. Is this moving while in telescope too, sir? While it is a moving only, sir.
Moving, right?
Yes, sir.
Okay. So can you explain about this L2 point, Lagrange points? They are Lagrange points, right?
Lagrange, yes, sir.
So there are how many of them?
They are in five Lagrange points, sir.
Okay. So how many celestial bodies are okay for the Earth Sun system? You have a Lagrange point. Do you have Lagrange for the Sun and Mars system?
Sir, I couldn't understand your question, sir.
So do you have Lagrange point for Sun and Mars?
Yes, sir. For Sun and Earth only, Lagrange point 2 will play a major role, sir, because
No.
L2 is a very shorthand for the second launching point and wonderful accident for gravity and orbital. Sir?
Ajit, just listen my question. Is it peculiar for Sun and Earth, or you can find Lagrange points for Sun and Mars also?
Okay, sir.
No, just
I think so. It is Sun and Earth. Sun and
Earth
Earth
only you can get, right?
Earth only, sir. Yes, yes, sir.
Okay, fine. Okay, fine. All the best.
Thank you, sir. Thank you so much.
Thank you, Ajit, for your PPT. Now it's time for vote of thanks. Gratitude is a quality similar to electricity. It must be produced, discharged, and used in order to exist at all. Pleasant afternoon to all. It gives me an immense pleasure to deliver the vote of thanks for this event to all dignitaries assembled here. I hope that today inspire ideas and discussion around the ways that we can understand and enjoy physics. I would like to thank our honorable judge, Dr. B. Muruganandam sir, who honored this function with his inspirational thought. I would like to thank our beloved Vice Chancellor, faculties, participants, volunteers, and last but not least, our beloved audience for making this function a grand success. Once again, I thank one and all present here. The result will be announced tomorrow at validity function. Thank you. All of you, you can leave now. Sir, thank you.
Thank you.
Done for video.
நேம் வாசிக்கிறேன். அவங்க நேம் ஆறு டீம் இருக்கீங்களா? கன்ஃபார்ம் பண்ணிக்கோங்க. பிக் டிப்பர்ஸ் இருக்கீங்களா? ஹலோ, தென் கேமரா ஆன் பண்ணுங்க. பிக் டிப்பர்ஸ் கேமரா ஆன் பண்ணுங்க. ஓகே, செகண்ட் டீம் வந்து கிரைன் கேலக்ஸி இருக்கீங்களா? கிரைன் கேலக்ஸி இருக்கீங்களா? நெக்ஸ்ட் வந்துட்டு கிரைன் கேலக்ஸி இருக்கீங்களா? கேமரா ஆன் பண்ணுங்க. கிரைன் கேலக்ஸி கேமரா ஆன் பண்ணுங்க. ஓகே, நெக்ஸ்ட் வந்து காராலாஃப்ட் லாட் நம்பர் 40 காராலாஃப்ட் இருக்கீங்களா? இருந்தீங்கன்னா கேமரா ஆன் பண்ணுங்க. காராலாஃப்ட் இருக்கீங்களா? இருந்தா கேமரா ஆன் பண்ணுங்க. ஓகே, நெக்ஸ்ட் டீம் ஸ்டிங் பைரேட்ஸ் இருக்கீங்களா? நெக்ஸ்ட் கேமரா. நெக்ஸ்ட் கிங் is 936.36 voltage. Now we are going to next question. The question is, consider the Lagrangian L is equal to A dx by dt the whole square plus B into dy by dt square plus cxy, where A, B, and C are constants. If px and py are the momenta, conjugate the coordinates x and y respectively, then the Hamiltonian is, the time starts now. The Henry's use legendary transformation connecting Lagrangian with the Hamiltonian. Answer is px square divided by 4a plus by square divided by 4b minus cxy. Next, the next question is, find the current density corresponding to the wave function psi of x is equal to a e power minus alpha x. So time starts now. Use the following expression as J is equal to h cross divided by 2 mi into sin star dou psi by dou x minus dou psi star by dou x into psi. Seconds more. The answer is 0. The fifth question is the Hamiltonian in a classical one-dimensional half object is h is equal to half p square plus x square. In suitable units, the total time derivative of the dynamical variable p plus root 2x is. Your time starts now. Use Poisson brackets of the variable. The hint for fifth question is use Poisson brackets of the variable and the Hamiltonian p plus root 2x qp. Seconds more. The answer is root 2 p minus x. The sixth question is assume that the Earth revolves in a circular orbit around the Sun. Suppose the gravitational constant g varies slowly as a function of time. In a particular, it decreases to half its initial value in the course of 1 million years. Then during this time, what happens to the radius of Earth's orbit? Your time starts now. 5 seconds. Timer. The answers. It will be twice the initial value. Now we are move on to 7th question. If y is equal to 1 over tan hx, then what is the value of x? So time starts now. The hint for the 7th question is replace tan h by sin h over cos h and substitute for sin h and cos h in terms of e power x and e power minus x. Timer. The answer is ln root of y plus 1 over y minus 1. The next question is, consider an ideal gas whose entropy is given by S is equal to n over 2 into sigma plus 5r ln u by n plus 2r ln v over n, where the n is number of moles, sigma is constant, r is the universal gas constant, u is the internal energy, and v is the volume of the gas. The specific heat at the constant pressure is then given by. Your time starts now. All participants are requested to turn on their camera. Sorry? Okay, Karen. பட் சீக்கிரம் வந்துட்டு கனெக்ட் பண்ணுங்க, நாங்கள் நெக்ஸ்ட் கொஸ்டினுக்கு மூவ் ஆன் பண்ணிடுவோம். டைம் அப் பண்ணா நான் நெக்ஸ்ட் கொஸ்டின் மூவ் ஆன் பண்ணிடுவோம். Seconds more. The answer is 7 over n. Next question. The equation of motion of a force simple harmonic oscillator is x double dot plus omega square is equal to a cos omega t, where a is constant at resonance works equal to omega. The amplitude of the oscillation at large times. Your time starts now. Okay, wait a minute. செட் பண்றா அளவு குடுறா. சார் பர்மிஷன் கொடுத்தாச்சு. 1.5 minutes more. Timer. The answer is increases linearly with the time t. The next question is the operator has an representation 2, 1, 1, 2 in the basis of span by 1, 0 and 0, 1. In another basis span by 1 over root 2, the matrix 1 and 1, and 1 over root 2, 1 minus 1. The matrix representation of A is your time starts now. One minute more. In seconds more. Timer. The answer is 3001. The next question is which of the following terms when added to the Lagrangian L of x comma y comma x dot compute y dot of a system with 2 degrees of freedom? will not change the equations of motion. The options are A x x double dot minus y double dot. Option B is x y double dot minus y x double dot. And option C is y x dot square minus x y dot square. Option D is x y dot minus y x dot. Your time starts now. One and a half minutes more. The answer is x double dot minus y x double dot. Sorry, x y double dot minus y x double dot. In case 60 is நீங்க ஆன்சர் பண்ணிட்டீங்க அப்படின்னா டைம் ஸ்டார்ட் பண்ணிடுங்க. Now we move on to next question. The 12th question is a spectrum is related. But